Good day, grade 12. So today we are going to look into series and sigma notation, but we are going to focus on arithmetic series, okay? So with me here, you can see that we have got what we call the sigma notation. So this is the sigma notation that we're talking about here. And the sigma notation, it's actually represents sum of, okay? It's a sign for sum. Okay, so you'll be summing in here. Then addition. So then the series here, I think you have seen that we have been doing sequences. And now we are moving to series. So series just also means the same thing. You are adding. Okay, you are adding. So instead of actually having the sequence of terms, now we are having T1 plus T2 plus T3. It goes on like that, okay, up until Tn. So in this case here, this is representing what we call a series, okay? Now, on the sigma notation, it's actually again showing us that you are going to add terms from term number m to term number, number n. So n here will be your last term, okay? The number that you see on the top of the sigma notation will be the last term, okay? Then the number that you see here on the bottom there will be the first term, okay? Now, let's say, for example, here you are given, and what we have here will be the expression. Let's say we say here, maybe let's say 2m. So it means that, let's just say this is representing what you're going to do when you substitute from, let's say, from, let me just say 2k here. So it means that you're going to first add what you call substitute for k from first say m 2, 3 goes on like that. But let's just do something that you can understand here. If I'm to write maybe something like this, k is equals to 1, then up to k is equals to 3. Okay, in this case here, we're going to have maybe, let's say 3k here. Now, in this case here, to calculate this, so this question will come and say calculate. So what you are doing here, you are adding the first term that you're going to have there. It's going to be 3. You substitute 1, which is the first year, then plus 3, which you say 2, then plus 3, then you have got 3, which is the last term. So it is all these are the things that are represented by the sigma notation here. To say 3k is our expression, and we're going to say 3 times 1 is going to give us 3, plus 3 times 2 is going to give us 6, plus 3 times 3 is going to give us 9. And if you add this, 9 plus 6 is going to give us 15, plus 3 is going to give us 18. Okay, so this is going to be our answer. But another thing that you also see that in the sequence, sometimes they were asking us to find n, which is the number of terms that you'll be having there. So n, in this case here, number of terms. So here, number of, or nth term, number of terms. How do we get number of terms? In this case here, we know that we have got, if we have got m, n here, k is equals to m, k equal to m, it means that number of terms here will be m minus n plus 1. Okay. No. Last term is n minus m plus 1. Okay. So for example here, if we are to apply this to what we have here, we'll say number of terms here is going to be 3 minus 1 plus 1, and which it means that how many are there? It's going to be 3 terms. As you can see there, we have got this first term here, the second term here, and the third term here. So we only have 3 terms in this case, T1, T2, T3. So this is how you find number of terms. Now, let's get to some questions for you to understand it better. Write the following series in sigma notation. So we can also be given the series, and the series is represented with a positive here, with the addition sign. And if we are to represent it in sigma series, first thing that we need to do is to determine the general term. So first thing, determine the series, type of series. Number 2, you need to determine general term, the general rule. The general rule, how to find the general term or general formula. to find nth term. So in this case here, you will say, okay, let me look at this. 3 minus, if you say 3 minus 2, 3 minus minus 2 is going to give us 5. 8 minus 3, so you have got negative 2 here, 3, then you've got 8, then you've got 13. Okay, then if you have to subtract there, we see that there's a difference of 5, difference of 5, difference of 5. So in this case now, we know that, oh, it means that this is an arithmetic series. So you can see that we can now see, because what is it that we find? We find the general constant difference, because of constant what? Difference. Constant difference, which is our D. And our D in this case here, our D will be equals to 5. What is our A? A is the first term there. So this is our A. A is equals to negative 2. Then how do you get the general term? General term, we know that we say Tn is equals to A plus n minus 1, what called D. What is our A? It's negative 2. What is our we put our n minus 1 there. What is our D? D is 5. Now, let's see what we get there. It's going to be negative 2 plus, so it's going to be plus 5n minus 5. Then you can see what we have here is going to be 5n minus 7. So now this is the general term. So this is how to find Tn. So with this equation here, we can now see that this is what we have here. N k equals to m, then Tn. So in this case here, we know that we're going to say our Tn. How do you get our Tn there? We know that Tn is 5n minus 7. So how do you present this in the what do you call, in the sequence? So we're going to have our sigma notation here. What do we have here? We are going to have n, and what do we have at the bottom? We're going to have k. You can say k is equals to 1. Okay, then what do we have here? We're going to have our formula now. Our formula, we must put it in bracket, 5n minus 7, like that. Okay, so it means that if you put 1 there, 5n is going to be 5 minus 7. You're going to get negative 2. If you put 2, you're going to say 5 times 2 is going to give us 10 minus 7, it's going to give us 3, which is the 3 that we have here. Okay, so this is how you present it on the as a sigma notation. That's our final answer. Now let's move on to the next question here, which is write the following series in sigma notation. What do we do now? We need to determine the general term for the series first. So if it says 6 minus 3, it's going to give us 3, but 12 minus 6 is going to give us 6. But in this case, you can see that it's not giving us constant difference. So it's not an arithmetic series. So what are we going to do? We're going to try another one where we're going to say 6 divided by 3 is going to give us 2. 12 divided by 6 is going to give us 2 as well. So in this case here, if we are saying T2 divided by T1, well, we're getting 6 divided by 3, which is going to give us 2. Then if you say T3 divided by T2, we're going to say it's going to be 12 divided by 6, going to give us 2. So what are we having here? We are having a geometric sequence, a geometric series. So this is a geometric series, geoseries. I'm just saying geoseries here. Okay, with r equal to 2. Okay, with our first term, our a is equals to our a is equals to 3. And how do we know? What do we know about this thing? We know that Tn is equals to a r to the power n minus 1. What is our a? Our a is 3. So here the general formula here is going to be 3. Then we have 2. Okay, n minus 1. So this is our general term. So what are we going to have now in a sigma notation? Sigma notation here, we're going to have something like this. We have got our n there, and we have got our k equals to 1. Then our general term here, our general term, we'll plug in our general term there, says 2n minus 1. So in this case, it means that with this sigma notation, we can actually determine the series. We can actually determine what type of series do we have, because we can find the first term, we can find the second term, we can find the third term, goes on like that. Okay, now let's move on to the third one. So the third one here is 6, 13. 13 minus 6 is going to give us 7, I think. Then here, if you subtract, you can see that there's the difference here is actually I would call it, it's 9 here, and there is no constant difference in that case. But also, if you say 13 divided by 6, we don't see constant ratio here, because in this case here it was constant ratio for geometric series. Then let's now move on to this. What I can see here is that I see something like what you call a quadratic sequence. So if you're having 13 minus 6 is going to give us 7. 13 22 minus 13 minus 30 is going to give us a 9. Then 33 minus 22 is going to give us 11. And what do we see if we subtract again here? We are going to get 9 minus 7 is going to give us 2. 11 minus 9 is going to give us 2. So it means that we have got second constant difference. But what we have learned from quadratic sequence is that we have this as our 2a. Then we have this first difference as our 3a plus b. Okay, and we have our first term as a plus b plus c. So we can now use this to find the general rule, which is what we need to first find. Now, what are we going to do? We're going to say 2a is equals to 2. In this case here, we are going to have our a as 1. A is going to be equals to 1. Then we say 3a plus b is giving us 7. Then we put 3, 1 there, because we already have our value of a there, plus b equals to 7. Then what we see that b is going to be equals to 7 minus 3, which is going to give us 4. So now we have now a and b. So we can now look for c. So a plus b plus c is going to give us 6. Then we have a is 1 plus 4 plus 6 plus c is going to give us 6. Then to get c there, c is going to be equals to 1 plus 4 is 5, so 6 minus 5 is going to give us 1. So c is equals to 1. Now our general term, our general rule that we know is that we say Tn is equals to an squared plus bn plus c. So we have got a, we have got b, we have got c now. So we are going to substitute for a. A is 1, so it's going to be n squared plus, what is our b? B is 4, so it's going to be plus 4n. Then what is our c? Our c is 1, which is going to be equal plus 1, like that. So now, how do we plug it in on the sigma notation? On the sigma notation, we're going to draw our sigma notation here. Then we have got our k equals to 1. Then our general rule here, the last term is going to be n. Then our general rule here is going to be n squared plus 4n, 4n plus 1. But we must always remember to put in brackets, okay? So you can just put in brackets just to to make it one term like that. Okay, so this is what you need to do when you are when they ask you to represent on a sigma notation. You are still finding the general formula or a general rule, then you just plug it in on the sigma notation, and you always have your k equals to 1 as your first term. Okay, now let's move on to the second scenario here, where we are now looking at the summing of arithmetic series. Now we are focusing on arithmetic series now only. Now, when you are summing arithmetic series, you ask you to find, we have the formula here. Now, this formula here, this is the sum of n terms, okay? Sum of n terms. Then this one, our nth term, the position of the term. Then our a is still our first term. Our d is still our constant difference or common difference. Say common difference. So our d is common difference. Now, we can, if we are given last term, we can also simply say our sum of n terms is going to be equals to n over 2 in bracket a plus l, a representing our last term, and this is how we find our last term. Okay, now let's look at this equation here where we're asking to find the sum of the series. So what we need, we know that the formula we need to find n. Our n is given because we're told that 100 terms, so n is going to be equals to 100. What about a? A, we know that here we are given it is negative 14. What else? What else is left there in the formula? In the formula, we are looking now for d. D is constant difference. So we're just going to say minus 9 minus 14, which is going to give us plus. So it's going to be minus 9 minus going to give you plus 14, which will get minus 9 plus 14 is going to give us 5. Okay, so we'll get our DS5 there. Now, to write our formula now, our formula Sn is equals to n over 2, in bracket 2a plus n minus 1 d. So in this case here, we're just going to plug in what we have. We're just going to plug in what we have. What do we have here? Our n is 100 over 2. Our 2a is negative 14. Plus, what is our n? 5 minus 1. D is, no, not n. N is 100. N is 100 minus 1. Then our D is equals to 5. If we are to plug it in our calculator there, so this is what we get. We're going to get 23,350. 23,350. Okay. So this is our answer that you will get there. So also see if you're going to get the same thing. So this is what you do. When you're looking for sum of n terms, you must get your n. Check, make sure that you get your n, you get your a, you get also your d, so that you can plug it in your formula. Now let's also have this calculate two. We can start from this what we call this is our equation here, but our problem is not, it's not a big problem, because what we know is that we said we need n. How do we get n? N number of terms. We say the 50, the top term, remember, 50 minus 2, which is the bottom term, plus 1. Now this is how we get how many terms we have in the what you call in our sigma notation there. Now in this series, we're going to have 50 minus 2 is going to give us 48 plus 1 is going to give us 49. So its n is 49. Now, what about our a? How do we get our a? Our a, we know that this is what is n will be 1. So we put 1 here. We put 2, sorry. The first term here is having 2. So it's going to be 5 minus 2 times 2, which will get 5 minus 4 is going to give us 1. So our first term there is 1. What about our d? How do we get our d? To get our d, we are going to get the series. So you're going to first say the first term here, first term is 5 minus 2 in bracket 2. Then the second one is going to be 5 minus 2 in bracket 3. Okay, the third one here is going to be 5 minus 2 in bracket what call 4. So in this case here, this is what we're going to have here. So you can do that. This is the first, third term, second term, and the first term. And what we'll get there, we'll get 1 already. Then here, if we say 5 times 5 minus 2 times 3 is going to give us 6. So 5 minus 6 is going to give us what are we going to get here? Negative 1. Okay, then if we say 5 minus here we have got 2, so it's going to be minus 8. It's going to give us minus 3. So what you will see that if we say minus 2 minus 1, you're going to get minus 2. Then if we say negative 3 minus 1, it's going to give us negative 2. So it means that our d in this case is negative 2. Okay, that's what we have. So we have our a, we have our n, we have our d. Now we can now use our formula. Sn is equals to n over 2 in bracket 2a plus n minus 1 d. What do we need to substitute? Our n is 49 over 2. Here, outside here, inside we're going to say 2 times 1, which is going to give us 1, plus n minus n, which is going to be 49 minus 1 times a negative 2. So here, this is what we have. Let's see what we'll get there. So what you get here, you're getting negative 2,303. Negative 2,303. Okay, so now some of you are asking yourself, how come we're getting it as a negative? How come we're getting it as a negative? Yes, we can, if you are adding terms, they can give you negative, because here you can see that we are adding negative terms. It's more like we are saying negative 1 minus 3. Like even if we are adding these first three terms, you are going to see that if you're adding only these first three terms here, some of the three terms here that we have here, we're going to say negative 1 plus minus 1 plus minus 3. What you get here, y minus 1 is going to give us 0, so it's going to be minus 3. So that's the sum for this what you call terms that we have already here, these first three terms. Okay, but this is not, it's important, yeah, it's important for you to understand. But let's move on to the second question that we can have also. How many terms are there in the series of this? Now, when we are given something like this, we don't need to stress ourselves. If we want to get how many terms, remember what we need to do to get how many terms. We know that we are given something here, which is our last term. And our last term, we use formula Tn is equals to A plus n minus 1 d. That's how we get our last term. So our last term we are given. So this is our Tn. What about what is short here? A, we can also find it because A, this is our A negative 3. What about D? D is the common difference. We can also find it. So we can see that this is not much of a problem, because when we are looking for how many terms, we are looking for n. So our n is actually in question in this case. So we're going to say, okay, our A, we are given our A. This is our A. What about the D, which is a common difference? 1 minus 3 is going to give us 1 plus 3 is going to give us 4. So 5 minus 1 is going to give us 4. So we have got D here. Our D, we have it. Then what is short now? Because Tn, we have it. So we're just going to plug it in here. 313 is going to be equals to our A. Our A is the negative 3 plus, what is our N? We are looking for N, guys. Then our D is actually 4. So in this case here, we're going to have 313, okay, is equals to negative 3. Then you can take N inside. It's going to be plus 4N minus 4. Then you can now see that you're going, what are you going to get there? So here, if you have to take the negative 7 there, it's going to be positive. Then 320 divided by 4, we're going to get 64. So it's 64. Our n is 64. What else do we need here? We are done. So now a number of terms is what call mean terms is actually 64 terms. Okay, so 64 terms. Our n is 64. Now, what is the sum of the series? Sum of the series. Let's write our formula, guys. Sn is equals to n over 2 in bracket 2a plus n minus 1 what call d. Okay, but in this case here, do we need to use this formula? Remember, here we are going to have our n over 2 2a plus l, not 2a plus l, sorry, a plus l, a plus l. Our L is our last term, guys. Our L is our last term. So in this case here, we are going to plug it in now and say, okay, we are going to have something like this. Sn is going to be equal to 64 over 2 divided, what call in bracket, we've got negative 3 plus 3 13. Okay, now this is what we get from there. Let's see what we get there. So we can see our answer there is 9,920. 9,920. This is what we get. So I think you guys, you're understanding what's happening here. Now, determine M in each of the following arithmetic series. So in this case here, we are looking for m. So how do we get m? How do we get m, guys? Now let's see what we have here. To get m here, we are actually looking for n. Now how do we get n? This is what we're going to do. We're going to say, okay, we need to write the series. So write down the series. So write down the series. What is the series? We start from the 2 here, 2, 1, minus 7. That's the first term. Then the second term is going to be 2 in bracket 2 minus 7. That's the second term. The third term here is going to be equals to 2 in bracket 3 minus 7. So can you see what we're doing? The first term, we need to plug it. Where there is p, we put 1. That's the first term. The second term, where there's p, we put 2. We go on like that. 1, 2, 3, we go on like that. Now, what are we going to have here? In the first term here, 2 minus 7 is going to give us negative 5, okay, plus. Then here, 2, which is 4, 4 minus 7 will give us negative 3, okay. Then here, 6 minus 7 can give us negative 1. So can you see what we're having here? We are having, what is it, negative 5, negative 3, and negative 1. We are adding as we go on like that. But we can now simply get our, so here, what are we given here? What we are given here is our Sn. This is our Sn that we are given, because this represents the sum. So if we add all these sums, we will get our Sn, which is 1015. So we know that in our formula here, in this case here, we are looking for n. We are looking for n. Now, we're looking for n, which is actually our m. Okay, we are looking for m, which is actually our n. So in this case here, we know that if we are writing our formula there and say Sn is equals to n over 2, 2a plus n minus 1 d. Now, what you will see is that we are given Sn. We are given a. We are given d. So we have found a and d, in fact, but we're given Sn. So in this case here, our a, we know now that is negative 5. What is our d? Our d, if we say minus 3 minus 5, you get minus 3 minus 5 is going to give minus 3 plus 5, which is going to give us 2. So here, and if you say also minus 1 minus 3 is going to give you also a positive 2. So here our d is equal to 2. Now, what else can we also look for here? We know we want n in the formula. In the formula here, we are looking for n. So we are now going to plug it in and say our Sn is equals to 10,000 and 1015. Let's now come and write everything here. 1015 is equals to n over n. We don't have n over 2. 2a is 2 times negative 5, okay? Then here plus n minus 1, our d is equals to 2. So we can now see that we are looking for n in this case. So we just need to simplify what we have inside here. Let's see what we do, what we get if we simplify what's inside there. Okay. Okay, now we can see that if what we find here, we get 2n minus 12, then we take the n over 2 inside, you get n squared minus 6n, because n over 2 times 12 is going to give us 6n. Then we take the negative, the 1015 to that other side is going to be negative. Then we are saying now this is equal to 0. Now, in this case here, we know what we need to do. We multiply the first term and the last term, which will give us negative 1015, okay, n squared. Then we look for the terms. And how do you look for the terms now? We know that we're going to say n here, n here. Then how do we look for the terms? We come here, we punch in what we get here, what we have here, which is 1015. We say equals to, then you say shift fact. Now, if we say shift fact here, this will supposed to give you the factors that you can use here. So if you can see that we've got 5 times 7, which is equal to 35, and we have 35 times 29, which is going to give us this. So what we have, we've got two numbers here, which is 35. So let's have 35 there. and 29. Okay, and if we add these two, if we say if we subtract the two, we say 35 minus 29, we get a 6. So in this case here, which need to be negative here? The bigger one needs to be negative and the smaller one needs to be positive for us to get negative 6 here. So our what we're now going to plug in here is going to be n minus 35, then n plus 29. Okay, so in this case here, our value there for n is going to be equals to 35, or n is going to be equals to negative 29. Okay, now our value can never be negative. We can not have the position as negative. We cannot say our value is at negative 29 at the term, or negative 40 term. No, we can't have a negative as a position. So in this case here, we're going to take our n as 35. So this is going to be our answer. Okay, so I think you now understand how we are supposed to do, how we're supposed to calculate, Tn, how we're supposed to calculate the sum of n terms, then how we're also supposed to find the n itself. Okay, so that's the practice work for you guys. You need to submit this to me after the lecture. If you have any challenges, don't hesitate to contact me on the following on the above what called mentioned contacts. Okay, thank you so much. Until next time, bye bye.